Welcome to the YouTube channel Just Information. We will learn class 8 physics chapter pressure and Newton's law of motion. So today we will solve some practice questions based on the chapter. Our first to fifth question is MCQ based. So let's start. So first question is, which would be the least likely to sink into soft ground? Option 1 is an empty lorry with 6 wheels. Option 2 is an empty lorry with 4 wheels. Option 3 is a loaded lorry with 6 wheels. Option 4 is a loaded lorry with 4 wheels. I'll repeat the question and options. Question is, which would be the least likely to sink into soft ground? Option 1, an empty lorry with 6 wheels. Option 2, an empty lorry with 4 wheels. Option 3, an empty lorry with 6 wheels. Option 4, a loaded lorry with 4 wheels. Answer of this question is option 1, an empty lorry with 6 wheels. An empty lorry with 6 wheels. Second question is, when a ship enters sea from a river, one can expect it. Option 1, to rise a little. Option 2, to sink a little. Option 3, to remain at the same level. Option 4, to rise or fall depending on whether it is of wood or steel. I'll repeat the question and options. The question is, when a ship enters sea from a river, one can expect it. Option 1, to rise a little. Option 2, to sink a little. Option 3, to remain at the same level. Option 4, to rise or fall depending on whether it is of wood or steel. So the correct option is option 1, to rise a little. To rise a little. Now the third question is, a metal block is thrown into a deep lake. As it sinks deeper in water, the buoyant force acting in it, option 1, increases. Option 2, remains the same. Option 3, decreases. Option 4, first increases and then decreases. I'll repeat the question and options. A metal block is thrown into a deep lake. As it sinks deeper in water, the buoyant force acting in it, option 1, increases. Option 2, remains the same. Option 3, decreases. Option 4, no such conclusion. Option 4, first increases and then decreases. So the correct answer is option 2, remains the same. Remains the same. Now the fourth question is, the same body is immersed in two liquids, A and B, in succession. The extent to which the body sinks in liquid B is less than in liquid A. What are the conclusions that could be derived from such an observation? Option 1, the density of liquid A is more than B. Option 2, the density of liquid B is more than A. Option 3, the density of liquid A and B is same. Option 4, no such conclusion can be made. I'll repeat the question and options. The same body is immersed in two liquids A and B in succession. The extent to which the body sinks in liquid B is less than the liquid A. What are the conclusions that could be derived from such an observation? Option 1, the density of liquid A is more than B. Option 2, the density of liquid B is more than A. Option 3, the density of the liquid A and B is same. Option 4, no such conclusion can be made. So the correct answer of this question is option 2. The density of liquid B, the density of liquid B in succession the density of liquid B is more than A. So now the fifth question is based on a diagram. The diagram shows a simple mercury barometer which height is a measure of the atmospheric pressure. So I'll write the diagram. I'll draw the diagram. This is the mercury barometer. This is length A. This is length B and this is length C. Like this. Then the whole D length is this. Length D. And this is filled, the mercury barometer is filled till this. Till point C. Like this. So the options for this question is option 1 is D, option 2 is B, option 3 is A, option 4 is C. I'll repeat the question and options. The diagram shows a simple mercury barometer which height is a measure of the atmospheric pressure. The diagram is this. Option 1 is D, option 2 is B, option 3 is A, option 4 is C. So the correct answer of this question is option 4 D. Option 4 C. Now let's move towards the subjective type questions. So our first subjective type question is, the question is, given that both liquid A and liquid B exert the same amount of pressure, what would be the height of column of liquid A if the density of A is twice the density of B and height of the column of liquid B is 10 centimeter? I'll repeat the question. Given that both liquid A and liquid B exert the same amount of pressure, what would be the height of column of liquid A if the density of A is twice the density of B and height of the column of liquid B is 10 centimeter? So liquid A, here liquid B. This is very easy question. So the formula is given. P is the formula is P of A, G and HA. PGH is the formula. This is the pressure of liquid A and height of liquid A. Here pressure of liquid B, G and height of liquid B. So now this is the formula. There it is shown to us that 2P B HA is equal to PB into 10. The density is, the height of liquid B is 10 and the pressure of liquid A is twice the liquid B. So that's why this is capable. Now we will transpose. We have to find the height of container A, height of liquid A. So height of liquid A is equal to PB. P means pressure of liquid B into 10. This will get transposed. 2 into pressure of liquid B. Pressure of liquid B and pressure of liquid B will get cancelled. 2 ones are 2, 5s are 10. Therefore, height of liquid A is equal to 5 centimeter. This is the correct answer. I hope you have understood. Now let's see question number 7. So the question is that in a typical Brahmas press, a force of 20 Newton is exerted on the smaller piston of area 0.5 meter square. 0.05 meter square. Find the force exerted by the larger piston on the load if it has an area of if it has an area of 0.5 meter square. I'll repeat the question. In a typical Brahmas press, a force of 20 Newton is exerted on the smaller piston of area 0.05 meter square. Find the force exerted by the larger piston on the load if it has an area of 0.5 meter square. Let's solve the question. So, given F1 is equal to 20 Newton, force on smaller piston next, A is equal to 0.05 meter square, area of smaller piston is equal to 0.05 meter square, then force applied on second larger piston is equal to what? On larger piston. So the area applied on force 2 is 0.5 meter square. Applied on second piston is 0.5 meter square. The formula is F1 upon A is equal to F2 upon A. We have to find the value of F2. So this will get transposed. So F2 will be equal to A into F1 upon A. Now we will put the values. F2 is equal to, the larger piston's area is 0.5 into force on smaller piston is 20 Newton upon the smaller piston's area is 0.05. So F2 will be equal to 5 by 10 if we will convert the decimal into fraction into 20 upon 5 by 100. So this is compound ratio, compound fraction. So we will convert this. So 100 by 5 multiplied with this whole. 0 will get cancelled. 5 ones are 5 ones are 2 into 100. F2 force 2 force applying on larger piston. F2 will be equal to 2 into 100 Newton. Therefore force applying on larger piston is equal to F2 is equal to 200 Newton. So this is the correct answer. I hope you have understood. Let's move towards the next question. And the question is question number 11. It's also an easy question. The question is that a stone weighs 650 Newton. A stone weighs 650 Newton in air and 275 Newton in water. Calculate its relative density and take G is equal to 10 meter per second square. I'll repeat the question. A stone weighs 650 Newton in air and 275 Newton in water. Calculate its relative density. Take 10 meter per second square. Now, so according to the question, there is stone and substance. Stone is substance, is the substance. And weight in air of the stone is given as 650 Newton, and weight in water of stone is given as 275 Newton. Now weight in water is 275 Newton. So, and G gravity due to acceleration is 10 meter per second square. So we have to find the relative density. What is relative density? So there is a formula to find relative density, that is relative density is equal to weight in air upon weight in air minus weight in water of the substance. So let's put the value and find out the relative density of the substance. Here weight in air of the substance stone is 650 Newton upon weight in air, again it is 650, minus the weight in water of stone is 275. By subtracting the value in denominator, we get 650 upon 375. By simplifying, we'll get 130 by 75. If we will simplify this by 5 7s are 35, 2 carried, 5s are 25. Here 5 ones are 5, 1 carried, 5 3s are 15, 0. Like this. Again we'll simplify it by 5. 5 ones are 5, 2 carried, 5 5s are 25. Here 5 2s are 10, 3 carried, 5 6s are 5 6 are 30. 26 upon 15. And if we will divide 15 by 26, it will be 15 ones are 15. Remainder will be 1 1. Here point 0 7s are 105. Then we will get 5, then 0, then 3s are 45, and so on. The value of this relative density of the substance stone will be 1.73. 1.73. I hope you have understood. Now, our next question. Question number 9 is. Question 9 is too much interesting, and it is a ball weighing 4 kg of density 4000 kg per meter cube is completely immersed in water of density 1030 kg per meter cube. Find the force of buoyancy on it given G is equal to 10 meter per second square. I'll repeat the question for you all. A ball weighing 4 kg of density 4000 kg per meter cube is completely immersed in water of density 1030 kg per meter cube. Find the force of buoyancy on it given G is equal to 10 meter per second square. So given is mass of ball is equal to 4 kg. Density of ball D is equal to density of ball is equal to 4000 kg per meter cube. The thing we have to also water's density is also given, that is 1030 kg per meter cube. The thing we have to find is buoyancy. Now the thing given is G is equal to 10 meter per second square. Buoyancy is equal to VdG. Volume into density into G. So we have to find V is equal to what? So first we know the formula, mass is equal to density into volume. Then volume will be equal to mass upon density. So we'll put value. Volume is equal to mass is 4 upon density of ball is 4000. So 1 upon 1000. Therefore volume is equal to 1 by 1000. Then we have to find B is equal to VdG. We have to find buoyancy. B is equal to 1 by 1000 into density of water is 1030 into 10 because it is the value of G. 0 0 cut 0 0 cut. Remaining B is equal to 1 into 103 is equal to 103 upon 10 as it is. Now we'll convert this into decimal, so therefore buoyancy is equal to 10.3 Newton. This is the final answer. Buoyancy of the substance, buoyancy is equal to buoyancy is equal to 10.3 Newton. I hope you have understood whole questions till this. For any queries and doubt, you can join the Telegram link given in the description of this video. Like this is the foundation of class 7th. We have covered the foundation of class. As this is the foundation of class 8th, we have covered the foundation of class 7th too. The links are given in the description. Please go and check through it. For any queries and doubt, join the Telegram link given in the description. I hope you have understood till this. Let's meet in another part with another topic. Thank you for watching.